what we said about solving exponential equations when we cannot make the base the same. There are two possibilities, one where x is in both exponents or powers and one where x is only in one. So in our first example here, we see we have x in both powers. So we're going to apply a log to both sides. We can apply a log of any base. I'm going to apply the common log again. In the next step, we write our powers as factors. Notice I'm not using brackets because those powers were monomials. They didn't have more than one term. I don't have to open the brackets. The next step said we wanted all of our terms with x on the same side. We see that x is common. Now we could divide both sides by that factor, but you should know that if we have 0 in the numerator, x is going to have to equal 0. And remember, we don't need to check our solutions here because our domain is the set of all real numbers. In question 2, we have x in a single power. That means we can simply change this to log form. Why don't you do that? Now we can subtract 3 from both sides. And we have our value for x. It's that simple. And remember, even though we don't put brackets here, we understand that this log has to be evaluated, and then we subtract 3. Now, I want to show you what many of you are going to do. You're not going to practice enough. And all you're going to remember is that you should apply a log to both sides. Notice I'm using the natural log. Now we can write our power as a factor. Open the brackets. Keep our terms with x on one side and our terms without x on the other side. And then divide by that factor. Now these answers don't look anything alike, but let's evaluate each of these on a scientific calculator. So when we substitute both of these into a calculator, we see that they are both approximately equal to -2.390. Here's another way to check that these answers are the same, even though they don't look exactly the same. Instead of applying a natural log, I'm going to, on the right-hand side, I'm going to apply log base 14. So here I would have log base 14 of 5 minus 3 times log base 14 of 14 all over log base 14 of 14. Now remember, this equals 1. This equals 1. This gives me exactly the same answer that I had over here. Log base 14 of 5 minus 3. So you can apply a log to both sides. But when there is x in only one power, it is so much easier to change it to exponential form. I hope you can see that, and I hope that that's what you practice. Let's do another question together. So we see that we have x in both exponents. So we're going to apply a log to both sides. Let's apply log base 2 to both sides. Remember that it doesn't matter what base we use, as long as the base does not equal 1 and is greater than 0. So now we have our factors, our powers that we need to write as factors. Do you notice what happened on the left? Because I chose to use a base that was the same as the base in my power, This log base 2 of 2 equals 1. So we just have x plus 1 left on this side. We need to have both of our terms with x on the same side. Why don't you finish solving this equation? So we took both of our terms with x, moved them to the same side of the equal sign. Both of our terms without x on the other side of the equal sign. Factored out our common x and divided. Your final answer should look like this.